In each of our 3 units, we've been talking about how to determine if functions are even, odd, or neither. And we've looked at the transformations in the table. We've looked at the graphs with the symmetries according to the y-axis and through the origin. And we've now taken those transformations and symmetries and done them algebraically. Remember, a function is even when it's reflected over the y-axis. Well, when you reflect things over the y-axis, you're taking the opposite of the inputs. And so that's what this function notation is representing, that the original function is the same as when you take the opposite of the inputs, reflecting it over the y-axis. A function is odd when it has symmetry through the origin. Well, if we're doing that, that's taking the opposite of the inputs and the opposite of the outputs. If those two functions are the same, those transformations are the same, then the function is odd. So again, we do our test with our original function. We take the opposite of the inputs and see what results. We take the opposite of the entire function and see what results. And if either of these two statements are true, we could classify it as even or odd. If neither of them are true, it would be a neither even or odd function. So we're starting off here with number 6, f of x equals x to the third minus x squared minus 1. And so we're going to look at those two transformations, reflecting it over the y-axis and looking at it through the origin. So I'm going to set up both of those transformations, and then I'm going to simplify. So the opposite of the inputs, again, since we have powers here, we want to think, what does that mean? Well, if something's to the third power, that means we have 3 of them being multiplied together. So a negative times a negative is a positive, times a negative would be a negative. Here, x squared, okay, so we have 2 of these squared, so we've got a negative times a negative, which is a positive, and it's being subtracted. So when we take the opposite of the inputs, we get a negative x to the third minus x squared minus 1. When we're looking at our symmetry through the origin, right, taking the opposite of the entire function, we're distributing essentially a negative 1 to each term. So we have negative x to the third plus x squared plus 1. Again, with the results of these tests, we want to see even, odd, or neither even or odd. So here's my original function. I want to see, does it match any of the other two transformations? This one does not match the opposite of the inputs, and it does not match the opposite of the outputs. If I look at the two transformations, they are not exact matches either. So we'd have to classify this as neither even or odd.